Hello and welcome to my video on the substitution reactions of benzene. First off, we'll talk about the general mechanism of electrophilic substitution for benzene. So, electrophilic substitution reactions occur in benzene chemistry because of the delocalized ring of electrons above and below the plane of carbon atoms. The electron-dense ring attracts and the electrophile accepts a pair of pi electrons from the delocalized ring to form a covalent bond. An intermediate forms that contains both the electrophile and the hydrogen atom that is being substituted. The delocalized pi electron cloud has been disrupted and the intermediate is less stable than benzene. So the unstable intermediate rapidly loses the hydrogen as a H+ ion. A delocalization ring reforms and the stability is then restored. So step 1, 2 of the delocalized electrons are donated to the electrophile, forming a covalent bond. So a covalent bond is formed from the A+ ion. To step 2, the CH bond breaks and 2 electrons return to the delocalized ring. So two electrons moved by the curly arrow, electrons are moving to the delocalized ring to reform it. So A is then bonded where the hydrogen used to be and the H+ ion is now formed. So we'll look at the two examples you need to remember for this unit. So a mixture of concentrated nitric acid and concentrated sulfuric acid is used. The sulfuric acid is needed to generate an electrophile from the nitric acid. This is the nitration of benzene, as I talked about last tutorial. So the electrophile is a nitrile cation. It is generated using the same equation that I mentioned in the last video. So nitric acid plus sulfuric acid makes NO2 plus, making a hydrogen HSO4 minus plus water. Same thing. So the electrophile bonds to benzene, and then the CH bond breaks, forming the delocalized ring of electrons again. NO2 bonds where the hydrogen used to be, and then the H+ ion just breaks off. So electrophile bonds, CH bond breaks, NO2 is replaced, hydrogen is replaced by NO2. So this is a good way to remember it, but in order for the H+ ion to cancel out, it can react with the HSO4 minus ion to reform sulfuric acid. So the catalyst actually regenerates. So the formation of bromobenzene requires a halogen carrier. So a halogen carrier is aluminium bromate, iron bromate or iron itself, or in the case of chlorination, aluminium chlorate, iron chlorate or iron. Iron can be used for either bromine or chlorine, and it forms the iron-free halides. When I say free, I mean it has oxidation number of 3. So again, electrophile bonds, CH bond breaks to reform the delocalization ring, hydrogen is replaced by bromine, H+ ion then reacts with the iron bromate minus ion to form FeBr3 plus HBr. So that's it for this tutorial. If you can remember this general reaction step and knowing that the halogens need a carrier, then it will save you a lot of learning later on. These general reaction steps is usually what happens for the nitration and the halogenation of benzene. Luckily you only need to know about the halogenation and the nitration of benzene, but if you can remember it for nearly any halogen, because it happens in exactly the same way. So if you take chlorine now, Cl2 plus iron chlorate makes Cl plus FeCl4. So the same thing would occur, just replace bromine with chlorine, and the H+ ion will be generated, and FeCl4 plus H plus will regenerate FeCl3 and would also make hydrochloric acid in the process. So remembering the chemistry here generally is key, rather than remembering a whole set of reactions. I hope you found that helpful.